Welcome to my presentation on Bipolar Junction Transistor. Myself, Anand Silvakarthik, Assistant Professor, Department of ECE, Hindustan College of Engineering and Technology. The contents are introduction, transistor structure, transistor operation, followed by its common base common emitter configuration, transistor biasing, and Q point. Introduction. The transistor is nothing but a device. It can act as an amplifier or a switch. And basically it is a current controlling device. There are two types, one is NPN as well as PNP. The NPN is most commonly used. The main thing is the current is flowing away from the emitter and it is of N, P, N, N. Whereas collector belongs to N type, base belongs to P type, whereas emitter belongs to N type. Transistor structure. BJT is a consists of 3 layers and a 2 PN junction, whereas the diode consists of 1 PN junction. You can see here the N and P, where this N is nothing but collector and this P is nothing but base. The junction is base collector junction, whereas the other is base emitter junction. Transistor operation. For normal operation, EB junction is forward biased, whereas the collector base junction is reverse biased. Apart from this, the input section of our configuration is always forward biased, whereas the output section is always reverse biased. And based on this forward bias and reverse bias, we'll be getting the depletion width, which is narrow or else wide. Transistor normal operation. Normal operation in the sense, I have told you before, the input section is always forward biased, whereas the output section is always reverse biased. Once if it is forward biased, the current will be flowing in this direction, whereas in this condition, the depletion layer width gets increases and there will be some current at the collector, it is of very minimum current. So this is what the transistor normal operation based on the diode concept. Just if it is PN junction, if once if it is forward biased, this depletion layer will get easily breaks down and there will be a flow of current, as well as here the width gets increases, so there will be minimum current flow based on the minority carriers at this particular point. The same content as I said before, and you can see here 3 currents can be identified in BJT. One is emitter current, base current, and collector current. And these are the current directions, but the generalized formula is emitter current is equal to collector current plus base current for both NPN as well as PNP. Transistor configuration. It consists of 3 configurations. One is common base and common emitter and common collector. And we'll be seeing in this presentation about common base and common collector. Common base configuration. I have told you before, the input section is always forward biased, whereas the output section is always reverse biased. Whereas this base is N and this is P and this is N, where you are calling this as a common base configuration. So the base terminal is common to both emitter as well as collector. Next is common emitter configuration. Emitter should be common to the other terminals, collector as well as base, and this is input section, whereas the other is output section. Base is P and this is N and this is N. So P type is connected to a positive terminal, N type terminal is connected to negative terminal is connected to N type. This is emitter. So this is forward biased. The output section is by default it is reverse biased, where emitter is common to base as well as collector. Transistor biasing. You can see applying an external DC voltage to ensure that transistor operates in the desired region, that is commonly called as a transistor biasing. For an amplifier action, the transistor should be operated in active region. For a switch application, it should be operated at the cutoff and saturation. Q point. The Q point is also called as the operating point, where we'll be going for DC load line analysis, and after we'll be fixing the Q point like this, where in general Q point is in the middle of the active region. That's all about the basics of BJT. Thanks for watching my presentation.